This presentation will show how carbon monoxide is produced when burning natural gas. It is for general information only and should not be used for design of gas equipment. If you have any further questions, please call Greg Hager on 039251 3024. Topics that will be covered is what is natural gas and where do we get it from? How does natural gas burn and what are the requirements for it to burn? How much oxygen is required to burn natural gas? Also how much air is required to burn the natural gas completely? And what happens if there is insufficient air to burn the natural gas? Also, what do the Australian standards require for ventilation for gas appliances? What is natural gas? Natural gas is part of the hydrocarbon group of gases, and the content of methane within that natural gas really depends on where it's extracted from. The methane content could be up to 88 to 96%, and the rest of the gases could be nitrogen, sulfur and other types of gases. Natural gas is not normally 100% methane, but for our demonstration here I'm going to consider it 100% methane for this explanation. How does natural gas burn? For any substance to burn, which includes natural gas, it requires three things. It requires heat or an ignition source, it requires the fuel, in our case it's natural gas, and also it needs sufficient oxygen to complete the process. For any substance to burn, including natural gas, it requires the correct amounts. For instance, if we had 100% gas within a room and we tried to light a match within that room, the gas would not ignite because 100% gas will not burn, and also it does not have any oxygen within the atmosphere. How much oxygen is required for natural gas to burn? Generally speaking, 1 part natural gas requires 2 parts of oxygen to burn. Therefore, for 1 cubic metre of natural gas, you require 2 cubic metres of oxygen to make it burn. Now we know that 1 cubic metre of natural gas requires 2 cubic metres of oxygen. We need to find out how much oxygen is in air, because we will use air to burn the natural gas. Generally speaking, there is 21.9% oxygen in air and 78% nitrogen, carbon dioxide and other trace elements. Therefore, in 10 cubic metres of air, there is 2 cubic metres of oxygen. Therefore, 1 cubic metre of natural gas requires 10 cubic metres of air, which has 2 cubic metres of oxygen within that air. From this chemical equation, you can see how methane gas burns. There will be 1 part methane, 2 parts oxygen. There's a chemical reaction, then carbon dioxide is produced, water is produced, and heat is produced. In this chemical equation, you can see that there is insufficient ventilation, therefore there is insufficient oxygen. So on one part of the equation, there is methane gas, there is 3 molecules of oxygen, therefore on the following part of the equation, there is carbon monoxide produced, plus water, plus heat, which means it is a dangerous thing to do. This is a pictorial representation of a space heater burning 1 cubic metre of natural gas. You can see there's 1 cubic metre of natural gas going in, 10 cubic metres of air, which means 2 cubic metres of oxygen. The flue gases that are produced due to this combustion process is there is 0% methane gas going out the flue gases, there is no oxygen going out the flue gases. The only thing that is going out is carbon dioxide, some nitrogen and water vapour. With this pictorial representation of a space heater burning insufficient air, it shows there's 1 cubic metre of natural gas, 8 cubic metres of air, which means there is insufficient oxygen for the burning process. The flue gases after the complete combustion that goes out the flue way is no methane gas, there will be no oxygen, but carbon monoxide will be produced, nitrogen and water vapour will also go out the flue gases. Any gas appliance other than a room sealed type gas appliance shall be ventilated as per the Australian Standard 5601. An example of a room sealed gas appliance would be a ducted heater, which is on the outside of the building and draws its air for combustion outside the building. Any internal space heater that draws its air for combustion from within the room shall be ventilated as per 6.4.4 in 5601. This shows that if it is in a plant room or not in a plant room, there are certain requirements, and also if it draws its air directly from outside or via an adjacent room, there are other requirements as well which should be looked at. In this presentation we've had a look at what is natural gas, we've had a look at how does natural gas burn completely, we've had a look at how much oxygen is required to burn natural gas, and it is generally speaking 1 part natural gas to 2 parts oxygen. We have looked at how much air is required to burn natural gas completely, and generally speaking it is 1 part natural gas to 10 parts air. Then we have had a look at the production of carbon monoxide due to insufficient air to the natural gas burner, and lastly we have looked at the ventilation requirements as per Australian Standards 5601 for any gas appliance within a room. If you have any further inquiries, please call Greg Hager on 03 9251 3024. Thank you.